we are coming up with another type of cryptography concept, that is polyalphabetic ciphers. Here, this is another way to improve on the simple monoalphabetic techniques. So here, through a plain text, we are trying to convert it to a ciphertext, that is encryption and decryption concept. So there are certain features in common among this polyalphabetic cipher. That is, a set of related monoalphabet substitution rules are used, and a key determines which particular rule is chosen for a given transformation. So original cipher says that in this scheme, the set of related monoalphabetic substitution rules consisting of 26 Caesar ciphers which shift 0 to 25. So here you will have a table of letters from A to Z, row wise as well as column wise. So column wise you're checking with the plain text values, and the row wise values you're checking with the key letters. So what happens in this case? It says that a given letter X in the plain text with the given letter Y in as a key letter, the intersection of the plain text value and the row value is taken. For example, if you're taking plain text B and key as C, you have to take the row key value as the row labeled and plain text labeled column value. Okay, so that value will be considered in the cipher text. So let us see this with an example. Show you an example. Here we have taken a plain text, that is geeks for geeks, and keyword Ayush, plain text geeks for geeks, keyword Ayush. Now these two has to, using these two words, we have to obtain the corresponding ciphertext. Now if you see, geeks for geeks are totally 30. These have 13 characters, whereas these are only 5 characters. So how will the intersection take place, and what is the value you will consider the key letter for all the 13 letters in the plain text? So what is done here is, what is the basic rule is, you have to repeat the keyword in a circular manner until it matches all the characters of the plain text. Okay, that is, if you see here, Ayush, 5 letters, again Ayush is repeated, then Ayu, that is 13 key letters should be available for this plain text word geeks for geeks. So how this encryption takes place? Okay, the first, what is the keyword we are using? What is the plain text? Geeks for geeks, and this is the keyword. So the first character that is matching the both is, one is G with A. So G is of the plain text and A is of the keyword. So let us see in the table, that is the Vigenère table, how this works. So we have to go column wise G, search for G, and row wise A. So A is here. So which is the match found? That is G. Okay, so this will be the corresponding first letter of that ciphertext of the plain text G. Okay, next, what is the next character here? It is E and Y. E and Y. So we have to see what is the matching value. So where shall we search E? E is here. Where is Y? Y is so Y is here, E is here. So what is the corresponding value? That is C. So the next corresponding, first was G, which we obtained. Next is C. Next, what we had is, here you have E, again you have U. So for E and U, what is the value? E is here and for U is here. So the corresponding line for E is Y. Okay. And value we are obtaining is Y. So same thing we are going on doing. So we obtain GCY. Next is for K. It is with S. S is with H and so on. So we are going to obtain a ciphertext value that is GCYCZFLMLYLEIM. So this is how we convert a ciphertext to a plain text. So plain text to a ciphertext. Also, the same rule can be used for the converting a ciphertext to a plain text. It can be done in a reverse order. You know the key, will know the ciphertext. So use the same concept to check the intersected row and you obtain the corresponding plain text. Taken another example as well. Here I am saying we are discovered, save yourself. Okay, this is the word that is being used. What is the key use? Deceptive. So the length of the plain text is more than the length of the key. So that is why we have to use the key again and again in a circular manner. Okay, so here it has been taken 3 times. Check the row, check the column and write the corresponding ciphertext here. Transposition technique. So here this is a different kind of mapping done here depending on some sort of permutation on the plain text letters. So the first one which you have technique used here is the rail fence technique. It is the simplest of this type of transposition cipher. Here the main concept is the plain text needs to be converted to the corresponding ciphertext. But here you don't use the concept of key. Okay, how is it done? Let us see. So here you have the plain text, meet at the schoolhouse. Meet at the schoolhouse is the plain text. This you need to convert to a ciphertext. So to encipher this, we are taking a rail fence of depth 2. That is the height is 2. So how it is being done? It is written diagonally. The letters are written diagonally in the 2-line format. Okay, that is first you write M, then you go for E. Again, E comes in the first row, first column E, second row, second column E. Again, the third letter again comes to the first row, fourth letter, second row, fifth letter, first row, sixth letter, second row, and so on. So here we can find that the complete plain text, it says meet at the school house. It is in this way. This permutation it is taken. Now, how do you write the plain ciphertext? You just first write with the first row and then come with the second row. So this will be the first one. This will be the second. So if you see here, you have MEATECOLOS. So that is what is given here. Till here, it is the first row. Again, ETTHSHOHUE. This is the second row. So this is how you obtain the corresponding cipher text. So next is the Hill cipher encryption. Here, Hill cipher is a multi-letter developed by mathematician Lester Hill in 1929. So this was the encryption algorithm that was developed by a mathematician. And the encryption takes the different plain text and substitute with its corresponding ciphertext by using the concept of matrix. Okay, how is it done? First thing what needs to be done is we have to give certain numerical value to each character in the letter. That is, first you have to number all the 26 characters A to Z. So you will have 26 characters. So it will be numbered from 0 to 25. Okay. Next, we'll see with the n cross n matrix. It can be done with 5 cross 5, 2 cross 2, 3 cross 3 also. But here we'll subsequently see on hillside 2 cross 2 matrix. So we'll take an example, taking the key as hill, Hill, that is the hill. So for H, what is the number? 7. L, it is 11. I, it is 8. Okay, we are taking it in a parallel way, 2 cross 2 matrix, right? So H, I, column wise. Okay, so you're taking parallel value H, I, L, L. Okay, what is the input message? What is the plain text value? That is short example. This is the plain text which you need to convert to a ciphertext using the key hill. So they are represented, the value hill is represented as HILL. Value will be 7, 8, 11, 11. This is a 2 cross 2 matrix, which you can see in this case. Okay. Now how we write this particular message in the form of a matrix? What is the rule that needs to be followed? So first letter goes to the top of the matrix and the second letter at the bottom of the first column. Okay, so it is like this. First letter is S. It is taken on the top. Second is in the bottom. Again the third again on the top. Fourth on the bottom, and so on. So we have a representation for short example. SHORTEXAMPLE. Okay, and we have to write the corresponding numbers which is being listed here. Okay, so here in this case for yes, what is the corresponding value? 18. So we write 18 here. For H, what is the corresponding value? 7. We are taking the value 7. For 14, for O, it is 14. R, it is 17, and so on. So we have made the we have seen the corresponding values as well here. 18, 7, 14, 17, 19, 4, 23, 0, 12, 15, 11, 4. These are the values that take place. Now for the next step, what should be the next step? We have to take the key value and we have to multiply with every pair of the plain text. Okay, so that is what we have separated here. No? We have to multiply it. As you all know, the basic rule of matrix multiplication. Okay, the row wise and the column wise concept. So here we have to use the same concept. In this case, you have A, B, C, D. This is the key and this is the first pair which we are taken of the plain text. So we are multiplying, it will be in this form, row value, column value. Okay, so you are multiplying AX plus BY, that will be in the first row, CX plus DY, that is in the second. Okay, same concept how we will be using to multiply with the numbers. So here, first, what is the key here? 7, 11, 8, 11. And what is the first value which we are seeing in this case? It is 18 and 7. So you have to multiply these two values. That is 7 into 18 plus 8 into 7. 11 into 18 plus 11 into 7, which you will be getting 182 and 275. But 182 and 275, how will you get the corresponding letter? Because the numbers are only from 0 to 25. There are only 26 characters. You have to convert this number to a corresponding letter. Okay, so for that we have to perform a modulo 26. Because why 26? Because we have 26 numbers, sorry, letters. And why modulo? Modulo says that you have to divide it by 26 and the remainder value is considered here. So in this case, 182 divided by 26, you will get the remainder as 0. 275 divided by 15, you will get, sorry, divided by 26, you will get the remainder 25. Not the quotient value, rather it should be the remainder value. Now for this, we can find the corresponding letters. For 0, what is the corresponding letter? It is A. And what is the other one? 15. 15 corresponding letter is B. So here you will have taken it as A, B. So the first text, that is S and H, is replaced by A and B. That is what is given here. Same thing, again we have to take it with the second value, that is 14 and 17. So you will be multiplying 7, 8, 11, 14 with, instead of 18 and 7, now it will be with 14 and 17. Okay, after multiplying you will get the corresponding value. What is after that corresponding value, you have to take the modulo. Take the modulo value of 26, then you write the corresponding letter, which will be A and D. Same way for the next two, it is JT, next is FT, next is WL and FJ. So finally we'll get the corresponding cipher text APAD JTFT WLFJ. I have taken another example here. Okay. In this case, I have taken the plain text as ACT and this is the key. Okay, and this obtaining the ciphertext later. So we have encrypted key ACT n equal to 3. What is the key? GYBNQ KURP. We have written the corresponding matrix value here. Okay, this is the corresponding matrix value 6, 24. So if you see here, I have made a table in this case. 6 is G, 24 is Y, and so on. Okay, so we are writing the corresponding value here: 6, 24, 1, 13, 16, 10, 20, 40, 17, 15. Whereas ACT is how many letters? 3 letters. So we are writing the first one A, C, T, corresponding value 0 to 19. So now we need to multiply this. Since it is only 3 letters, we don't have an issue. It is 3 cross 3 matrix with the key. So the plain text should also be written in a with 3 rows. Okay, so that it can be multiplied. 1 column, 3 rows. So here, since it is only ACT 3 characters, we have written like this. Multiply the key value with the corresponding message ACT, you get the multiplied value and you have to take the mode. When you are multiplying here, it will be in this form. Okay, it says 6 into 0 plus 24 into 2 plus 1 into 19. That you will obtain as 67. Next, it will be 13 into 0 plus 16 into 2 plus 10 into 19, which is you obtain 222. Next is 20 into 0. Next is 20 into 0 plus 17 into 2, 15 in plus 15 into 19, which you get 319. And after this value, obviously you will, it is not within 26 number 26, so that you can obtain the corresponding letter. So what you have to do, you have to take a modulo 26, that is dividing the value by 26 and then using the remainder value, which is 15, 14 and 7, where the corresponding letters are P, O and H. So the corresponding message for this ciphertext is P, O, H. Also you have for decrypting, because here you obtain the ciphertext that needs to be converted to a plain text. What time, at that time, what is possible? So again, this 15, 14, 7 is considered, but you can't take the key value, rather you have to take the inverse of that key value. Okay, the inverse value should be taken, then the mod value, multiply it with the corresponding value, will obtain the value. Okay, so you have to see how to decrypt a value from the corresponding value. Next is Fistel cipher structure. Let me come to 10 marks. Fistel cipher structure is, this is not a specific scheme of block cipher. Okay, it is a design model from which many different block ciphers are derived. Especially there is an algorithm called as encryption process called as DS is called as data encryption standard. Okay, so we cannot say that Fistel cipher is the basic scheme of block cipher. Okay, it is a cryptographic system. The DES is a cryptographic system based on this Fistel cipher using the concept of encryption and decryption. In the encryption process, there can be different rounds, round 1, round 2, depending on the structure of the system. Okay, so it uses the Fistel structure consisting of multiple rounds processing the plain text, because the plain text should be converted into a cipher text, and each round is constituting a substitution step followed by a permutation step. Here the plain text block is divided into two halves, left half and the right half. All the rounds will have the same structure. See, if you see round 1 here, okay, round 2 up to round n, everything is divided into the two halves, left and right. And what is the output obtained here? It is a ciphertext block. So a substitution is performed on the left half of the data. Okay, it is applied. Okay, this is done by applying a round function to the right half of the data followed by the XOR option. Okay, so what happens in the left half? You are using the concept of substitution. You are applying the round function. Okay, after applying the round function, you are implementing a XOR operation towards the right half of the data, and the output of that and the left half of the data both combined. So the next part will be the design principles. How many blocks of data will be involved? Now the depends on the block size. How many block size? It will be divided into 64 bits. So the plain text will be converted to 64 bits, whereas the key size, whatever key is used to convert a plain text to a ciphertext, will be up from between 56 to 128 bits. And the number of rounds, most of the time it will be 16 rounds depending on the structure. And you have a subkey generation algorithm, a round function here. So this is the main topic which you have to understand with respect to Fistel. And this Fistel cipher structures is implemented in the next topic, that is the DES, data encryption standard algorithm. So next we have data encryption standard. What is this data encryption standard? That is a DES algorithm. Okay, DES is a block cipher and encrypts data in blocks of size 64 bit each. So every block of data is converted or encrypted with a size of 64 bit, which means 64 bits of plain text goes as the input to the DES, which produces 64 bits of ciphertext. So the plain text is converted to a ciphertext. Since the plain text is of 64 bits, the ciphertext will also be of 64 bits. And the same algorithm and the key are used for encryption as well as decryption. What is the key length? The key length here will be of 56 bits. Okay, first point which you have to keep in mind is DES is a block cipher. It will use the same algorithm and the key for both encryption as well as decryption. For during encryption, the plain text is of 64 bits long, and it will obtain a output that is a ciphertext again of 64 bits, whereas the key length here will be of 56 bits. These are the basic points you have to keep in mind of DES. This is the first part. So if you see here, block 1, block 2 up to block n, different blocks it is divided into, or you can say rounds. Okay, the plain text is sent to this DS with the 56-bit key converted to a 64-bit ciphertext, and it keeps on for each and every block. Okay, so we have already mentioned here stating that key is a 56-bit, keys of length 56 bits, and initially the plain text is of 64 bits. So before the DS process start, we have to obtain a key with 56 bit. Okay, because usually a key will maybe of 64 bits, so we have to convert it to a 56 bit. And how is it possible? We are going to discard every 8th bit of the 64 bit key. Okay, we are converting it to a 56 bit. So if you see here, okay, every 8th bit we are removing so that we reach up to a 56 bit. So we obtain a 56-bit key value. After discarding the 8th bit from the 64-bit key, we are obtaining the result of 56-bit key value. This DS is based on two fundamental attributes of cryptography. One is called as substitution, another one is called as transposition. Substitution is also called as confusion, transposition is also called as diffusion. We have already seen with these definitions. This DES algorithm will consist of 16 steps, okay, each of which is called as a round. So as you had seen in Fistel cipher structure, there were n number of rounds, and it was told that there will be a total of 16 rounds. Each round performs the steps of substitution as well as transposition. So now let us discuss on the steps involved in DES. Okay, what are the different steps? So in the first step, 64-bit plain text block is handed over the initial permutation. Okay, that is the first step which you have to keep in mind, initial permutation function. So initial permutation function is performed on the plain text. Next, the initial permutation produces two halves. One is the left plain text, second is the right plain text. And each plain text will follow how many rounds? Totally 16 rounds of encryption process. Finally, after using the corresponding 56-bit key, then later on it is combined or rejoined, and a final permutation function is executed or is performed, and to produce the corresponding 64-bit ciphertext. Okay, so what is the first step? Your taking first step is a 64-bit plain text block is handed over to the initial permutation function. Then the initial permutation is performed on the 64-bit plain text. Next, the initial permutation produces two plain text, left plain text and a right plain text. Left plain text and right plain text are going through 16 rounds of encryption process. At the end of both left and right plain text, okay, where the encryption process takes place using the key, it will go through or it will be rejoined using the final permutation function. Then this final, after this process, you will obtain a result of a 64-bit ciphertext. So what was the input? 64-bit plain text. What will be the output finally? 64-bit cipher text. This is the usual process that takes place in a DES algorithm. So if you see the initial permutation, it will happen only once, as well as final permutation happens only once. But the left plain text and the right plain text, the encryption process takes place how many times? 16 times, which is mentioned as 16 rounds using a 56-bit key. Okay, initial permutations. Okay, the transposition in the initial permutation should be followed in a particular manner. Okay, saying that the first bit is replaced of the original plain text is replaced with the 58th bit. The second bit is replaced with the 50th bit. That is the initial permutation taken in this TS algorithm. Okay, saying that the first bit, if you see here, okay, the first bit is replaced by the 58th bit. So this will be the first. Second bit is replaced with the 50th bit. Third with the 42nd. Fourth with 34. Fifth with 26, and so on. Okay. Next again, till we reach the 64th bit. So 64th bit is replaced by which bit? 7. So this is the initial permutation table, because we have to convert the plain text to a ciphertext. So certain rules needs to be followed here. Okay, so here in IP, that is the initial permutation. After the initial permutation is done, the 64-bit permutated text blocks is divided into two half blocks. As you know, that is left and right. Each half block will consist of 32 bits. Okay, 64 bits is divided into two halves, which is obviously 32, and each 32 bits will get into 16 rounds. Okay, what will be included in those 16 rounds? But first is key transformation, second is expansion permutation, third is S box permutation, fourth is P box permutation, XOR and swap. Key transformation, we have initially 64-bit, which is transformed into 56-bit key by discarding every 8th bit of the initial key. That is what we have seen. And the output is we are obtaining 56-bit key. That 56-bit key is a different 48-bit subkeys generated during each round using a process called as key transformation. For this 56-bit key is divided into two halves, so each will be of 28 bits. And these will be circularly shifted left by one position or two position depending on the rounds. So first round it will be one part is 28, another part is 28. So it will be shifting left by one or two positions. So if the round number 1 to 9 or 16, the shift is done by only position for the other rounds, that is one position. The circular shift is done by two positions. Certain positions it will take only shift only by one. Some position it will be shifting by two. So here if you see in round 1 it will shift by 1, round 2 1, remaining all the other by 2. Again round 9 is 1, 16 is 1. This is how it is been shifted to obtain the corresponding key, because for each round the key will be different. After an appropriate shift, 48 of the 56 bit are selected. As it is being told here, 56-bit key, from this 56-bit key, a different of 48-bit subkeys generated, which is called a process called as key transformation. Now, how will we obtain this 48-bit key? This 56-bit key is divided into two halves, 28 and 28, and after every round, depending on each round, these are shifted circularly left by one or two positions. So if you see in this figure, round 1, round 2, round 9 and round 16 are shifted by one position. Remaining all the other rounds are shifted by two positions. After an appropriate shift, 48 of 56 bits are selected. Okay, for selecting that 48 of the 56 bits, the table is shown below. Like this. Okay. After the shift, the bit number 14 moves to the first position, bit number 17 moves on the second position, and so on. 3 in 11th, 4 in 24, and so on. Okay. So we realize that it contains only 48 bits. So that is how the selection is done. Okay. And bit number, if you see 18 is discarded, will not find, like that 7 others are discarded in order to reduce the from 56 bit to 48 bit. Okay, so this is called as compression permutation as well, because initially it was 56 bit key, now we have come for a 48 bit sub key. Next, if you see, you have expansion permutation. Okay, that is with respect to the right plain text. We have done with the left plain text. After the initial permutation, we had two 32-bit plain text areas called as left plain text and the right plain text. During the expansion permutation, the right plain text is expanded from 32 bits to 48 bits. Okay, bits are permuted as well, hence called as expansion permutation. So how does it happen? A 32-bit right plain text is divided into each block, divided into 8 blocks, each block consisting of 4 bits. Okay, each block will be consisting of 4 bits. Then these 4 bits are again converted to a 6-bit block. 200. So the permutation is increased. That is called as S box. And after that, you are performing the XOR operation. Okay, this process continues until you obtain with complete with all the bits. Key transformation process compresses the 56-bit key to 48 bits, whereas the expansion permutation process expands the 32-bit right plain text to 48 bits. So now what we obtained? We obtained a sub key of 48 bits and a plain text of 48 bits. So what next operation to be performed here? XOR operation. And the result output is going to next substitution, that is the S box substitution. So if you see the substitution here, it is divided into S box. These are the S boxes from 32 to 48 bit. So we are obtained a 48 bit value. After performing the XOR, we are passing it to all the S boxes. So what can we say? That the 32-bit value is converted to a 42-bit, 48-bit output combined with the 48 key, XORed with the 48 key. The output is passed on to the S boxes. So S boxes are totally 8, each of 6 inputs, 6-bit input to obtain a 32-bit output, each with 4-bit output. Okay, so it is illustrated below here. You have 6 bits, which has the permutation table here, S box table, which in turn converts it to a 4-bit value. So let us see how this has been converted. So you have a permutation for S box 1. I've given only for 1. There are totally how many S boxes? 8. So you will have 8 permutation for 8 S box permutations. Okay. So for example, if we have to convert from 6-bit value to a 4-bit value, so consider the input is 1000011. Okay, what should be the output? What we have to do is we have to write the first and 6th bits together, which is the first bit, that is 1, 6th bit is 1, combine it together, 1 in binary, which is 3 in decimal. Okay. The remaining values here are 0001 in binary, whereas it is 1 in decimal. So what we have to do is we have to look in row 3 and column 1 in the table S box 1. So this is the S box 1 table, third row and first column, the value we obtained is 12. In decimal, the corresponding binary value is 1100. So we say that 100011 produces an output of 1100. That is with S box 1. Similarly, you have for S box 8. Okay, consider the input is with 6 zeros. Okay, what can be the corresponding output? Again, you are combining the first and the sixth with 00 in binary, which is 0 in decimal. The remaining values are 0000 in binary, again, which is 0 in decimal. We are looking to the 0th row and the 0th column in which table is box 8 table, which we are obtaining 13 in decimal, 1101 in binary. So this is the way we are converting a 6-bit value into a 4-bit, and totally a 48-bit input is converted into a 32-bit. Next, finally comes the final permutation, where you are combining both the left plain text and the right plain text, each of 32-bit, to obtain the corresponding 64-bit. Okay. In this case, in that final permutation, the first bit will be the 16-bit, the second bit will be the 7th bit, and so on as the output, and you'll obtain the final 64-bit output. Sorry, final 32-bit output. Okay, in the final permutation, last operation in this DS function is this permutation with a 32-bit input and a 32-bit output. Finally, what happens? We are combining both the values in the final permutation, okay, combining to obtain a 64-bit cipher text. So finally, we obtain the 64-bit cipher text. This is DS algorithm, that is data encryption standard. Thank you, students.